Hello, today I wanted to make a tutorial on how to do some TCP connections or UDP connections, but focusing on how you have to send the information. Some people usually use JSONs or long strings to do their connections. The proper way to do that in video games is using bytes. In kind of a lower level situation, because we will be sending less information, so we can have more users connected to our database, or we can make things faster and so on. So I wanted to show you how did I make the data structures to store and send my net packets in the network. So the first thing that I want to show you is that I have here an enumeration with the packet types. That's what you can consider the action that we are doing. As you can see, this is a card game, so you can ping, shuffle, draw cards, set mana, like kind of Hearthstone thing, okay? I also have things like matchmaking, check opponents, and so on. So this enumeration is also set to take the size of a byte, because I want it to be exactly 1 byte, because I'm not going to have more than 256 actions. Each one of these will take the byte appropriate, so a ping will be the byte 0, shuffle would be the 1, draw card will be 2, etc. So I could have up to 256 actions. Then here I have my net packet. So what I did here is to use an unsafe struct. Unsafe meaning that I can make it work with pointers and more complex things. So what I did here is to specify where the bytes go for each one of the fields, or the variables, or whatever you like to call them. So in this struct, in the net packet, I'm going to be specifying where everything goes. So the first byte is going to be the size of the packet. If the packet is 32 has 32 bytes of size, it will be represented here under this size. Okay, I made it private, and I made a public getter. This might be kind of slow, but I believe Visual Studio does some optimization to the getter, so it should be okay to use it. The next byte would always be the packet type. Okay, same as with the size. The reason why I put the size on the first place is because when I get a network stream, long byte array, what I do is to pick the first byte, and that would be the size that I have to read for that packet. So if I'm the server and I get a byte that is an 8, that means that I have to read 8 bytes and treat that as a net packet. Okay, so here I have set to the position 0 every other packet here. The reason I do that is because I'm going to be sharing some memory between them. Every single of these packets has its size and its type. They've already have that set up in their constructors, and they overlap. Like, as you can see here, I have my different packets. For example, one simple packet is the setMana packet. So in the setMana packet, I have the size and the type on the first 2 bytes. So I can use them here in the net packet. Okay, so sorry. The next 2 bytes are the player who changes the mana and the amount of mana that it changes to. So when I create this packet, I only need information about the player and the mana that I'm going to be changing. I know the size of the packet is 4 bytes, 0 to 3, 4 bytes, okay, and the type is packet type setMana. Okay, so then I just add the player and the mana to the like parameters to this packet, and then this will be sent over to the client or the server or anything that needs to be sent to. So how do we do these conversions here? So if we wanted to, if we are receiving on the receiving end, and we get a array of bytes, what we are going to be doing here is to use pointers like this. So I take the pointer to that array, and what I do is to treat it like it is a pointer to a net packet, and I return the value of that pointer. Like this is a really fast conversion, because what I'm doing is take the bytes and treat them as a net packet, and that's returned in this function. So it's really fast to convert from bytes to the net packet. Then if my net packet, I just check the type. So if it is a setMana type, I just go to my packet dot setMana, and I can access both the player and the mana here. And again, to switch from the net packet to the byte array, it's a bit more complicated. But what I do here is to create an array, knowing that the size of the packet is already known, and here I do some movement, and I just copy manually the array to the net packet bytes, like here, to the array. Since these are bytes, I just use the this operator to scroll through them, and then return the byte array. I believe this can be done faster using maybe assembly or some marshalling code to just transform from net packet to bytes, but I didn't find how to do that. Still, I believe it's quite fast, so no problem on that end. So this is how I do my networking here. The main problem that I faced is that I need it to have every structure to be a fixed size, so I couldn't use strings because strings have a variable size. So what I did was to make here a fixed string class, which is just a signed byte array with UTF-8 encoding, with some static implicit operators to switch from fixed string to string, and the other way around. And that's more or less it. I didn't make any black magic or something like that. And actually, even though this is stored as a fixed string, I can return a normal string because of that implicit operator right there. And again, I can also use it like this in the other way. And that's how I made these packets here. Okay, these are all the packets stored. Remember, the size and the type always go first, and then we can just go to these properties and treat them like if were any other kind of packet. Also note that you have to write the field offset. So if you have something that takes 2 bytes, you should increment it by 2, like in this add cards to that packet. And I believe that's all you need to know on how to make good net packets for your games, which are faster than sending a JSON or a long string. This should be like probably the fastest way, because they are structs, so the new operator isn't as hard as in a class. You don't need to do any casting other than these two on the bottom here, which this is very fast. This one could be made faster, and that's it. Hope you've learned something good and to make a good online game from now on. Bye.